3.3 powers of I. So believe it or not, more than just I, the imaginary numbers, we can have exponents with I. And so let's go through and talk about what each of these would mean, because if you know I squared, I cubed, and I to the fourth, you can do any of these other problems, okay? So I, we know, is really the square root of -1. There's nothing we can do to simplify that, so let's just say that I is I, okay? There's no other way about it. I squared would be taking the square root of -1, because that's what I is, and squaring that. So we're doing like a substitution, saying because I is the square root of -1, I'm going to take the square root of -1 and I'm going to square it. What have we learned about squaring and square rooting? They cancel each other out. So whatever's under the radical, which is called the radicand, that's the answer. So I squared is really -1. You've got to remember this, and you will the more we practice it. Okay, I cubed is really the same thing as having I to the second times an I, right? That would make 2 plus 1 be I cubed. So let's replace things. I squared, we said, is -1 times I, which becomes -I. And then I to the fourth, we've got two options. We can write I squared times I squared, because 2 plus 2 would make 4, or we could write I squared, that quantity squared. Power rule also says 2 times 2 makes 4. But either way, we're having I squared, which we proved is -1, times -1, or -1 squared. Negative times negative is +1. So it goes I, -1, I, +1. And they're right over here in this little chart if you need to look back at them. But what happens is if I had I to the fifth, oh, we have it right here. I'll do it on this one. If I had I to the fifth, think about how we could rewrite that using these. The easiest thing to use is I to the fourth. So I'm going to always try to take as many I to the fourths out as I can, because what do we say I to the fourth equals? Simply 1. So I to the fourth times another I would make I to the fifth. I to the fourth we just said is 1. 1 times I is simply I. So it would start this pattern again. We went I, -1, I, 1. I to the fifth would be I. I to the sixth would be -1. I to the seventh is I. I to the eighth is 1. It just keeps going this pattern every 4. It keeps going. Okay. So number 2, 53. We're trying to think about how many I to the fourths are in that. So let's break that up. 53 doesn't divide by 4. What about 52? Yes, 52. So I'm going to write I to the 52nd power times another I. And if you can think about, okay, 52 divided by 4 was 13, I'm going to break this I to the 52nd power into I to the fourth raised to the 13th power, because this multiplies to make 52 times our other I. Well, we talked about how I to the fourth is 1. 1 to the 13th power is 1. 1 times I is I. Okay, I to the 103rd power. I wouldn't want to keep going in this pattern until I get to 103. So instead, let's think about 103 divided by 4. Probably won't happen because it's odd. Let's try 102. No. So then I have to keep going down. It wouldn't be 101. What about 100? Yeah, that would be 25, right? So I'm going to write this as I to the 100th power. But I'd need times an I to the third to make these add to be the 103 power. And then I to the 100 is really I to the fourth raised to the 25th, because that multiplies to make 100. And then still times this I to the third. So I get to where I know anytime I see I to the fourth raised to a power, or even up here when I see I to a power that's a multiple of 4, I just know this is 1. So 1 times I to the third, go up here and look about what that really was. That was -I. 1 times -I is -I. Number 13, we start getting bigger exponents, or we're having the product rule. We know that we need to add the 39 plus 9 when we multiply exponents, so that would be 48. 48 is already a multiple of 4, so I would write I to the 4th raised to the 12th power, so I just know this is 1. Number 14, I need to add the power, so 13 plus 6 would be 19. That would be 48. Oh man, I got the same one again. Right? I added that right? Didn't mean to get the same type twice. So again, I would see that that is already a multiple of I to the 4th, so that's 1. Why don't you pause and try number 15. Okay, all these powers add up to make I to the 86th power. I had to check, but 86 is not divisible by 4. You get a decimal. So I went down to 84, which is, and so right away I just know this is 1. So I can kind of ignore it because 1 times this is really my answer. I squared, if you go and look, I squared is equal to -1. So you're just trying to break things down into easier pieces to figure out what these big exponents really equal. And it's always got to be I, -1, -I, or +1.